At the state of neutral equilibriums, you have two possible solutions. You have two possible deformed state. One is the original one, and the other one is the deformed one. Okay? And in method of neutral equilibriums, for example, if I take this column, this is just a pin one. So at method of neutral equilibrium, using method of neutral equilibrium, okay, we try to find the loads, yeah, where this position, the straight one and the slightly bent one, is possible. So at method of neutral equilibrium, this shape and this shape both are possible. So if you are given any kind of columns, so what you should do is you should draw first what is the slightly bent. And what is the slightly bent configurations? And what is the slightly bent configurations that you can get depending on whether this is allowed, this is 0 or this is not 0, which is what is the end conditions, and whether the rotation is 0 or rotation not 0. So those are the things that we have to get from the problems. Is translation allowed or not? If translation not allowed, so V0. If it is allowed, then V non-zero. So that will affect the shape of this and also what kind of reaction that we have at the support. Is rotation allowed? If rotation not allowed, then you have moment. If rotation allowed, then you don't have moment there at the end. So this is a very important end condition that we have to know, plus the top one also, this part. This is 0 or not 0. V is equal to 0 or V not equal to 0 at this end there. Okay. So this one will affect your shape. What is the shape that will happen when this column buckle at the neutral equilibrium state? So the next thing that you have to do is you have to take this out. Okay, you have to take this out and you draw the, you have to cut this and then you draw the free body diagram. So here we have only this force because these are the force acting and we have also moment. Yeah? And because rotation is allowed, so we don't have moment at that end because it is spin. Okay? So these are the steps. Okay. If for other problem, then you have to draw other free body diagram, and then we have this is X here to here, and here we have the Y. Okay. So these are the steps that we have to know, and then here you have a P here, which is to balance this. Then you have this moment. Okay. So this is the first thing that you must be able to draw. Okay. And here, this is not allowed. So by right, we should, if it is not allowed, and it depends, we must have lateral force. But since if you put lateral force here, if you consider moment at this point, so the lateral force should be equal to 0 because there is nothing, no moment for the lateral force to resist. Okay. So is there any lateral force acting here? Any lateral force acting here? We have to look at the overall equilibrium. Because if you put lateral force here, then at this overall here, you don't have any moment that is produced here. So this lateral force becomes 0. So you don't have any lateral force here. Okay. Because there is no moment appearing here for the lateral force to resist, so you get 0. Okay. So it is important to draw this correctly so that you are able to form next the equations. So the next equations that we need to form is take moment at this point to become 0. So we will have okay. So the next step after you draw the free body diagram is take moment at this point becomes 0. So we will have moment negative DIY double prime. So this is in this direction and that one is negative. Yeah, this is in this direction and then you have another one which is DY 0 because this is in opposite direction. So from here you finally get to this and we divide this with EI, so you get this P over EI, Y equal to 0. Okay. And finally, we get this. Okay. This is ordinary second order ordinary differential equation with constant coefficient. So from there, you get the solution. Okay. So this is always the terms that will appear in any kind of column when we try to derive the governing differential equations under method of neutral equilibrium. So it will always, you will always get these terms here, but depending on the end conditions, so on the right-hand side, you get some other non-zero functions here. For this case, you get 0 here, and the solution for this, when this right-hand side is 0, will be this. For other case, when you have other end conditions, you are going to get on the right-hand side, not 0 anymore. So then you are going to get your solution plus something here. Okay. So that is the case for other end condition. But for this end condition, right-hand side 0, so you have only this homogeneous solution. And to determine A and B, you need to use the boundary conditions. That is, what happened at x is equal to 0, what happened to the v? So the boundary condition that we have here is when x is equal to 0, v is equal to 0. When x is equal to L, v also equal to 0. So that is the steps to get the boundary conditions. To determine this constant, we must use boundary conditions. So from here, we can get what is A and what is B. Okay. For these conditions, when x is equal to 0, y 0, you get B 0. Here you get B is equal to 0. Then from the second equation, we get 0 A sine KL equal to 0. And finally, from here, you can get the equations that the condition that will give you the P critical, which is a non-trivial solutions. A cannot be 0. If A is 0, then this Y becomes 0. You get back to the solution, which is a straight one. So for this one must be 0. Yeah, sine KL must be 0. Here you can get P critical is pi squared EI over L squared. Okay. Remember the K is square root P over EI. Okay. So class, this is the basic flow of method of neutral equilibrium. Of course, I use the simplest example, which is this is an Euler column. But if you have other conditions, then you have to take care of what are the first slightly bent shape that you can have if different n conditions. If it is fixed, what happens? If it is fixed free, what happens? Or if it is fixed, allowed to translate but not allowed to rotate. So what happened to this slightly bent shape? And then when you cut through this part of this slightly bent shape, when you draw the free body diagram, what are the end forces, the reaction forces that you might have at the end that will affect your this equilibrium equations. This is actually equilibrium equations. Then depending on what are the end conditions, you will get this right-hand side to be non-zero. When you have non-zero, then the solution will be, when this right-hand side non-zero, you have to plus something here. Okay? When this is not zero here, so you have to plus some these particular solutions depending on what is the form here. Okay. When it is right-hand side zero, then it is easier. Okay? You have only this solution. So that is what I can brief you on this method of neutral equilibrium. Okay, so if you are asked to use method of neutral equilibrium, depending on what are the column given to you, then you have to go through this process. So the important steps will be, what is the slightly bent shape corresponding to the end conditions? And from there, when you draw this free body diagram, what are the forces here? Do you have a shear force here? Do you have moment here? That will affect these equations. Okay? Of course, this, when you come to here, then it will affect whether your right-hand side is zero or non-zero. Then after that, it will be applying the boundary conditions. Use the boundary conditions that we know. Then finally, use the conditions of non-trivial solutions. We want to get P where this is possible. We want to get P where this and this is possible. Two solutions are possible. So from there, we decide which are the ones should be equal to zero. From there, you get the P critical. Okay. So that is the method of neutral equilibrium. First method that we cover very early on. Okay. Okay. So I will go to next method, then I pause for a while to see if you have any questions. Any questions so far? This? Okay. So this is method of neutral equilibrium. So you will get at the end partial differential equations, get the solutions, and then apply boundary condition, finally get to a equation that you need to solve to determine the P critical. The next method that I will cover is using the slope deflection equation method. Okay. I have to erase this. So slope deflection equation method, you will be given the equations that you need to use. Okay. And what you need to know is how to use those equations. So this is method using slope deflection equation. So slope deflection equation, we will have MAB equal to EI over L alpha N theta A plus alpha phi theta B. Okay. Then MBA is equal to alpha N theta B, follow the B there, plus alpha N theta A. Okay. So this alpha N and alpha F will be given a function. This is pi N minus, remember this, pi n minus pi f. Cannot remember this. This equation will be given to you. Okay, right, alpha n and alpha f. These equations will be given. You don't have to memorize that. This is for beam column. Okay, that is, if you have axial force. If you don't have axial force, if it's a beam member, then we have EI over L 4 theta A plus 2 theta B for theta B and 2 theta A. So those are the basic equations that you need to be aware of. This is for beam. There is no axial force in the problem that you need to solve using slope deflection equation method. This one is only used when you have axial force. When there is no axial force, it's a constant 4, 2, become 4 and 2. Okay? So that is the first basic equations that you need to be aware of. Okay? Then how to apply these equations, how to apply this set of equations, you have to first identify what are the rotation which are not zero. But of course, this is for the case where you have no relative translation. Okay? This is for the case there is no relative translation, which means the column n, they don't translate relatively. If you have relative translation, then there's another term added. Yeah, here you have to add one more terms. I give you one example how it is being applied. Okay, I show you the flow only, the process. If you have this is one of the questions, I think, possible situation where you can solve using slope deflection equations. So you have P here. So this is a column, beam column subjected to axial force. This is a beam, there is no axial force. So we can differentiate them and then know which set of equation we should use. Okay. Then normally we give this the name. This is A, this is B, this is C. Okay. So you identify first theta A, this is not zero. Okay. Theta B also not zero. And theta C also not zero. Okay. Those are the first thing that you need to know because it will affect your equations here. If it is zero, then one of these rotation will become zero. To disappear. So this is 3 degrees of freedom. You have three unknown. But if this is fixed, then the same thing here. Then theta A becomes zero, theta B not zero, and theta C also not zero. So this becomes 2 degrees of freedom. So it's important to know, looking at the problem given to us, what are the non-zero theta? What are the non-zero theta? Because that will appear in the equations. And that will also decide how many, the final equation that we want to solve is a matrix equations and how many equations we have to solve. So let me take the example of another one. Okay, let me do this one. Let's go to this one. Okay. And for this one, so we will try to form the join. We will find to join equilibrium equations where the theta b is non-zero. So we have to form the joint equilibrium equations where the rotation is non-zero. So how to form that? Is you look at joint B here. So at joint B, for rotational equilibrium, so moment at NBA coming from the column side plus moment at BC coming from the beam must be equal to zero. So these are the things that we need to, these are the equations that we need to get. Okay. There's question in the chat I will answer later. Okay. Let me finish this first. How to solve that? I think that is a very time-consuming process to solve for alpha n. So you have to guess the range. I think there's one way is to guess the range and then shorten that. Okay. I will come back to your question again. Yeah. So here the problem here is the flow is important, because finally you come to this question here, how to solve it. How to solve without using Excel is a very time-consuming process. That is correct. And we have to know what is the range, possible range of KL that we should use. Okay. I will come to that, I think. Yeah. Now, so we have MBA, which is the moment at this end coming from the column side, moment at this end coming from the beam side, equal to zero. So next you have to form the MBA for the column. So MBA for the column, you have to make use of the equations. So it depends on what is the EI here. So please pay attention to the EI here. The EI might not be all the time the same, yeah? This is L2, maybe this is L1. So we have to really pay attention to the column length, the EI of the beam, EI of the column, are they the same or they are not the same? So MBA column, we have to have EI over L1. I use the L1 of the column there, multiply with, space now. EI is a bit smaller. EI over L1, then you have alpha n. For that particular case, near for B will be theta B. And here is fixed, so becomes zero, so we don't have. Okay. So MBA over column is this. And M at the end, same NB, but with member BC for the beam. This is coming from the beam. Will be equal to EI, let's say the same. Beam, the length is different. Multiply with 4. The near one is theta B. The far one is C, so theta C. Okay. So when we have this, we can solve these questions by consider this as theta B and theta C, which is two different rotation. But you can also make use of the conditions of MCB of the beam is equal to EI over L2 4 theta C plus 2 theta B. Yeah, this N here. And C of beam BC is given by this, but this is a pin N, so this becomes 0. So you get the relationship between theta C, which is negative theta B over 2. This is to simplify this, and finally we have only one equation to solve. Okay. This is making use of these conditions. So if you have this, then we substitute here. So theta C is equal to negative 2 theta B, and BC of the beam now is equal to EI over L2 4 theta B plus 2 theta C. Right. Four minus 2, so you get 2 theta B. And 4 minus 1, 4 minus 2. So this is to reduce it now instead of theta B and theta C. So final equation, we need to solve only for one theta, which is theta B. So the next thing is this you have and this you have to add in here. This substitute here, this one substitute here, that will be equal to 0. So you get the equation that we need to solve for what is the P critical. Okay. I come here. Now you have this, you have this, you substitute this into the moment equilibrium equations of the joint. B must be equal to 0. Then we have EI L1 alpha N theta B plus three theta B equal to 0. Okay. So it depends, yeah, your L1 and L2, are they the same or not the same? So in this case, I can this. I assume here, okay, for simplicity, but if it is not necessarily the case, so L2 is equal to half of L1, which is this half only. So I get, so EI, they are the same. So EI over L1 and theta B plus 0. So finally we get 6 plus 1, 7. Plus 7. Theta B equal to 0. Okay. So when you come to here, the next thing is to know what is the equation that you want to solve. The equation that you want to solve is the one that gives you non-trivial solutions, or non-trivial solution, which is to get theta B not 0. To get theta B not 0, your alpha n plus 6 must be 0. Okay. So this is the equation that needs to be solved. So how to solve for this alpha n equal to 6? Okay. What is the value of KL that gives you alpha n plus 6 equal to 0? So the key point here is to guess the value. Yeah? What is the range of KL that we can? What is the range of the KL values that we can guess? This problem, this is fixed here. This one will be thin. Okay. So this is a column in the frame. So the critical here will be, of course, you need to be able to get it fast. So this one will be in between, okay? Fix. Okay. The P critical will be less than the fix one. I'm coming to your question now, how to determine the alpha n, because in exam you have limited time to get the alpha n even when you come to this stage. So you need to guess the value of alpha n. Don't have to start from 0, 1, 2, 3, 4, 5, 6 because it will take a long time to find where it is. So we need to make a guess. So the range of the KL value, it lies within which range? Okay? Greater than in. So the P critical here that we finally get from here would be greater than this case, which is fix and pin, because this is not really pin, but less than fix because this is not really fixed. So if we can guess this, so we know what is the KL value for this and what is the KL value for this. So we guess, yeah, we can know what is the KL value of this and what is the KL value of this. What is the KL value of this and what is the KL value of this? Then you narrow down the range. So in the exam, we do not expect you to get very accurate answer because we are not testing you on that. So you need to know, for example, how actually you get the solutions. So once we know what is the KL value for this case, what is the KL value for this case, then we can start with this plus this over 2. So see whether you get the alpha n value plus 6, you get positive or negative. So you compare with when you substitute the KL, yeah, when you substitute this KL value into alpha n, you get a positive value, and here you might get a negative value. Then you get the center one. Okay, you find the KL, this plus this over 2, substitute into here plus 6. So to see whether you get a positive or negative value, then you can guess whether it's between here and there and between here and there. So we do not expect you to go until very detailed, so maybe 2 or 3 times is enough to give us what is the approximate value of alpha n. Then from there, you get what is the value of KL that you should to satisfy these equations. Then from there, you get the P critical. Okay? So you square this, you have to find P critical after you determine the KL. Okay? After you get the KL, then you can get the P critical. So Ahmed, to answer Ahmed Ersekski, to answer your questions, I think I cannot read your. In slope deflection method, in solving moment equations leads to alpha n equal to 10. How to solve and find KL value? We have solved the same equation in the assignment and find KL value being XL. Okay. So how to solve this? You need to narrow down the range. I think then from there, narrow down the range and then further narrow it down and then find the approximate value for KL. Okay.